Hello everyone and welcome back to CSCI 301. Today's introduction to object-oriented programming will review and introduce key concepts. Some of you have just had object-oriented programming, some of you are taking it right now, and some of you have not taken it. I'm going to introduce a few of the key concepts and interpret them in the scripting context, so we'll all have a level playing field when we start talking about object-oriented programming in this class. Object-oriented programming produced a change in paradigm a number of years ago. The procedural program where you just had a list of instruction was the original thing that everybody started with. And you had your data over one place, you had your code in the other, and the two were separate. Well, starting actually in the early 60s, but gaining momentum in the 80s and 90s, was the idea of having an object which consists of the data and the methods or the functions bound together. And these objects were examples of what's called a class, which is essentially a blueprint for what turned out to be a very complicated programming structure. So like I said, the idea was you bundle your data and your code together in objects. So, some of the features of object-oriented programming, we'll go through these one by one. Classes, objects, abstraction, encapsulation, inheritance, and polymorphism. And I'll go through each of those and show you what they mean. Okay, a class is a blueprint or definition. An object is an instance of the class. And a class basically defines property, the data elements, and methods. And an object is a single instance of that class. Now let me pop open Alice here and I'll show you. Alice is kind of neat because it's essentially an object-oriented block language, which makes it kind of nice because it's really easy to understand. Okay, let me add an object here, and you see that's what they even call it. They call it objects. And let's see, who am I going to add? I'll add a people, and let's add Bob. No, actually, let's not add Bob. I'll show you why later. Always my favorite is coming up here. Random guy and random girl, my favorites. Okay, let's get random girl. We'll add her in here. Okay, and you can tell she's an object. It's a person. Now, if you come over here, you see that she's got these properties: left shoulder, right shoulder, lower body, head. Actually, she's got these objects that are part of her, because objects can be part of other objects. And she's got these properties. Now, right now, her property is that she's yellow. Now, we can figure that she's a Clemson fan, so let's make her orange. And she just kind of turned orange there. And magenta. Okay, see, she's turned purple. And let's turn her back. Okay, so she has properties. She also has methods, and I can actually do those methods. Random girl method, move, forward, 1/2 meter, and she moves. So you got the idea that you got your code that works on her, and then you got her properties. Those are all in the same object. Okay, let's see where I'm at now. Okay, we got object now. Okay, the class here is random girl. Where'd it go? There we go. But you see, I can name this particular random girl. You know, I'll call her Shirley. As in Shirley, you can name instances of a class and call them objects. Okay? And you see, now we might give her another new property. We might say birthday. And we'll call it a string. Okay, and we'll set it. We'll say she was born on April Fool's Day in 2000. Okay. Now, If I put another random girl in there, bring her up here a little bit. Okay, you see her name is not Shirley, and you notice she doesn't have that property. Shirley has it, random girl doesn't. Let's call her Laverne. And yes, that is this TV show for those of you that remember it. Okay, and let's get her birthday. Don't want her to be jealous. Well, she was born 06/01/2000. Nope, it's not like that. We'll call it birthday. Okay. And we'll tie 06/01/2000. Okay. All right. So now we go back to Shirley, and she's got a method called say. Shirley say, kind of like Simon says. And we'll have her say her birthday. Then we'll have Laverne say her birthday. Laverne say. Okay, we'll run that. Oops, got a little too much. Laverne's got a few more details. Yep, it took me literally. Okay. All right, let's rerun it again. Okay. Now notice, now you say, well, what happens if you want them to say the other's birthday? If you want Shirley to say Shirley's birthday, first of all, I'm going to make a copy. We'll drag it down here. And go to Laverne's birthday. Okay, and I'll get into why I'm doing that a little later. I'm just showing you kind of showing you how things are working. Okay, that means she can access her birthday, but she has to access it by calling her object. We'll get back to that in a little bit later. Okay, and we saw the property, we saw the birthday. I didn't use Fred this time. I figured that he needed a little break. Okay, this principle of data abstraction, this is something that your really object-oriented programs really respect. The idea is you cannot operate directly on the data from an object without going through that object, and that is essentially what we're doing here. Is in order for Shirley to have access to Laverne's birthday, she's got to go through Laverne, and vice versa, by the way. So, okay, now what happens is a really hardcore object-oriented language. You have getters and setters, and you have to call those to actually get or set the values, and a lot of those have methods built into them that prevent bad data. For example, here for birthday, there's nothing there's nothing here that prevents me from saying birthday is never. Well, that's not a real date, but what happens, a lot of them will have some code in here that will actually evaluate and make sure that you in fact give it a valid birthday. So that's data abstraction, is that prevents you from going right into the data and just changing it arbitrarily. Okay, code encapsulation is much the same idea, but it works the same for code. Let me find a dog here. You know, everybody likes dogs. Well, most everybody likes dogs. All right, animals. And we want that calm, cool, and collected creature, the husky. If you've ever known him, you know that I'm being facetious. All right. Now what happens is I can go ahead and say husky move to. Well, let's move forward. Move to camera. Move toward 1 meter. Let's let her move to Shirley. The entire Shirley. Oops. Okay. have it move up a little bit. Okay, we don't want to move the ground. We want to move Husky. There we go. No, we don't want to move his front. Okay. Husky method. Husky. Husky move. Up. Let's see what a half meter does. Okay, he's kind of floating in the air, but that's fine. Now, when we have a move, he just kind of moves all at once. It's not very realistic. Now, it turns out with a Husky, he's got another method. And let's see if I can find it. Husky methods, wagtail, walk cycle. Let's go ahead and run that and see what happens. And we'll have them do 2 cycles. Alright, they're going to go back and forth, and here he goes. Okay, now that's more realistic than him just moving. Of course, he's going right through Shirley here, but you know, you're learning another thing how to do that. You hear the cat in the background. Okay, so what happens is, now it turns out, let me show you what's all involved in the Husky walk cycle. Look at all of this. All that's involved in the Husky walk cycle, and you don't have to remember how to do all that and this, that, and the other. You just call Husky walk cycle, and the rest of it's kind of abstracted. It's kind of hidden from you. You just know that he's walking. Okay, inheritance. We'll talk about our Husky again. Okay, you notice that you've got these move, turn, roll, and all that. You notice Laverne and Shirley have those too. Okay, those are things that you have by just being an object. Now the Husky has inherited those. In addition, it can wag its tail. I guess the random girl can wag her tail, but it doesn't look the same. And I don't even know what an ambient wag is. It can bark or scratch its ear and sit and stand. It's got all of these additional properties. So it inherited all of the methods that most objects already have, and it added to it. That's inheritance. Okay, polymorphism. This one I had to think about how to. Polymorphism really means, poly means many, and morphism means forms in this case. So, if you think about steer, you know how to steer a car. Do you steer a bicycle the same way? Do you steer a ship the same way? Most people know how to steer a car, but if you ever tried it, backing with a trailer is quite different than the way you'd ordinarily steer a car. So the idea of steer is the same idea, but it's got different forms depending on what you're exactly talking about. And we don't get into a lot of this with us, but there's a thing called an abstract class where they simply define steer, and you have to define it for your object to say specifically what it means. And another example is tune. The way you tune a guitar is quite different than the way you tune a piano. And no matter how obvious or how plausible it may sound, you really can't tune a fish. Okay, dad joke. All right, so polymorphism, it's one of the features of object-oriented program, and it'll basically give you a set of functions called an interface, and you will say how those particular functions work in the particular case of the object you're making. So like for a car, you'd have a subject object called a steering wheel. A bicycle, you have handlebars. Ship, you'd have a rudder. Okay, let's look at our language and let's see how well they support object-oriented programming. Bash really doesn't. And by the way, command line in Windows doesn't really, because that's not what it's supposed to do. Perl actually has quite a bit of support for OOP, but it's weakly typed. That is that you can change. You do not have to declare the type of a variable before you use it, and it just kind of looks at what it is and treats it accordingly. So abstraction is not really fully supported. Now Python, we'll find out, does have a sort of data encapsulation, but if you know the secret behind it, you can bypass it. So it doesn't keep out people that want to break the rules. It just keeps honest people honest. Okay, JavaScript is also weakly typed. Now PowerShell and Racket support object-oriented programming pretty well. Okay, That's the end of this show. I hope you enjoyed it.